Assalamualaikum and good day to our beloved madam. Today we are from group 3 would like to explain about our coding for drowsiness detection system. For your information, function of this program is to detect people's eye whether it is open or closed even when the person is wearing a spectacle. So if you see in the line 43 import CV2, it is used to read the video, and then the import delete used for face recognition purpose using HOG, and the spicy spatial import distance used to calculate the Euclidean distance between eye aspect ratio. And then the next one is actually function calculate EAR. What's the meaning of EAR? Is actually the short term of the eye aspect ratio. A is used to calculate the distance between eye at coordinate 1 and coordinate 5. You can see the function of calculate here is used to measure the face landmark, and the face landmark in our face have total 68, but we only focus on our eye. And the coordinate of our eye starting with over here as coordinate 0, coordinate 1, coordinate 2, coordinate 3, coordinate 4, and coordinate 5. Because of that, you can see at the point A, it will calculate the distance between coordinate 1 and coordinate 5. We call it as Euclidean vertical. And then the distance of the point B is coordinate 2 and coordinate 4, still a Euclidean distance. And then the Euclidean vertical. And then the point C, calculate the distance between the coordinate 0 and coordinate 3, which is the Euclidean horizontal. And after we get the value of A, B, and C, we will put it inside the formula A plus B divided by 2 times C. And after we apply it inside the formula, that's what we call as ear aspect ratio. And we will return the value of ear aspect ratio into the calculate ear. And then in line 55, you can see the CB2.video capture is used for calling default camera. We are using the default camera because the value inside the video capture as 0, which is means our own camera on the computer. And then line 55, hot face detector. Line 58, delete face landmark, which is actually the total landmark of our face, which is 68 point in our face.
So I will continue the explanation about this code. So for y true frame equals to cap.read, it method is used to convert an image from one color space to another, which is it tells us to read image from what cam and image stored in the frame. So then gray equals to cv2.cvt color. It will convert BGR to grayscale, and the machine learning library is trained on the grayscale image. So for the faces equals to hot face detector gray, it was actually is basically a feature descriptor that is performed both for image processing and computer vision techniques. Mean detect faces using HOG face detector and passing grayscale image to HOG face detector. So for face in faces, it pass image to landmark detection, and it also used to detect and track key points from a human face, and face landmarks will be saved in this face landmarks array. So for left eye and right eye, actually will only want to detect the movement of left eye and right.
So from line 75 to line 86, this part of coding is actually to measure the distance between upper eyelid and below eyelid. So for line 75, it's actually to define that left eye will be defined with range 36 until 42. And then the range is following the 68 shape predator face landmark. Okay. So for line 76 and 77, it is here to tell you the point of X and Y based on the range given. For example, if we detect the point 34, then the n in the face landmark dot part bracket n will be 34. And then for line 78, this append here meant to add, which means the result of X and Y will be inserted into the array of left eye. Line 79, this next point here is to increase the n, which also means it will detect the next point. For example, here 34 will become 65. All of these will repeat until the n become 41 according to line 80, so that it can create a circle around the eye. And then for line 84 and 85, this x2 and y2 here are just the same as the x and y above, but instead of n, it's using next point. So cv2 dot line here in line 86 is just to draw a line based on those points that were detected. So that's it from me.
Okay, for line line 89, for an image 4248, it is to determine the position of coordinate at I to draw a circle around I. And then X interface landmark, Y interface landmark. And next to the line 94, right I dot append it is to define right I will be defined with range 42, 48. And then line 95, next point and plus 1, which is to see that what will come next after 42. So next, because we want to create a circle, so from line 98 until line 101, from that it will create a circle. Yeah, so in line 103, it will show CV2 dot line frame XY and so on. So I will pass to the next presenter.
Okay, for the next code, which is line 105 and 106, this is to passing the array using the left eye for loop and the right eye for loop to get all the 6 eyes coordinate to calculate the both left eye and the right eye eyes aspect ratio. And then for the next, we will add the left eye aspect ratio and the right aspect ratio and divide by 2 to find the average to make the system more efficient, because sometimes the people will close one eye or will partially closing their eyes that cause the system not work properly. And then for the average, we will round it to the 2 decimal point. And then if the eye aspect ratio is under 0.26, then the text of the "Are you sleepy" will appear on the frame. And then in the line 111 and 112, this is the setting of the text, which is the first is setting the pen setting, and the second is the font, then size, then color, and then the thickness. And then if we print "Are you sleepy" on the frame. And then for the line 118, this is will allow the user to wait until the key is pressing. And then for the code cap.release is for the closing a video file, and then the last is to destroy the window or close the window. Okay, goes to the next presenter.
Alright, in line 2 we have beginner import, which is to import the library. Then in line 4 we creating an instance of Windows. Next we have coding to fix our system window size, which in line 8 to resize the Windows to its minimum size, and in line 9 to fix to its maximum size. Next we have a code for our interface background color, which is set to black. Then in line 14 we are creating a title label where the title is set to white color and the background is set to red color. Then we use a Times New Roman font with sizing 30. Then the title label text is set to center and the box fill the x-axis. Then coding from line 17 to 25 is where the text for instruction label. It is shown in our interface. Then in line 28 to set the geometry of the window, and next is title window. And lastly, from code 37 to 41 is open and close function button on our interface. Then here in line 127 is coding for sizing button, where we will use in button settings function. And coding from line 129 to 130 is button setting for open and close button, where you can find on our interface. Both are set to almost the same setting. The difference between these two buttons is in open button we have active foreground function, which is set to red, where when we click the open button it turns red, and then the command is set to open file code. For close button, the command is set to close code. Alright, then this is our drowsiness detection system. When we click the open button, it will open a new window. Okay, so the camera window will appear. In our pie chart output, it will show the eye reading, and when we close our eye for a specific time, it will detect drowsy in output section, while in camera, it will show warning text in red color. Then, when button escape is pressed, it will turn off the camera. Lastly, exit button to close the program. That's all for our drowsiness detection system.